Hi, Ashish Kumar Chetri, roll number 20NS0322, Department of Physics, fourth semester. I'm going to make a video on the topic Windbridge Oscillator and Bristol Angle for paper 4. Starting with the history, the Windbridge Oscillator is developed by Max Wien in the year 1891. In 1937, filament lamp and active oscillations were developed based on the bridge circuit. In 1937 to 1938, various discussions on the negative feedback of the oscillations between Tom and Bill Howlett and Arad was the oscillator was then demonstrated first in Poland. Bill Howlett's first product, HB200A, manufactured in California, was a precise Weinbridge oscillator. Howlett's oscillators could produce the output in the form of wave with less distortion and stable amplitude. Introduction: a Wien-Bridge oscillator is a type of electronic oscillator that generates sine waves. It can generate a large range of frequencies. The oscillator is based on a bridge circuit originally developed by Max Wien in 1891 for the measurement of impedance. The bridge comprises 4 resistors and 2 capacitors. The oscillator can also be varied as a uh, the oscillator can also be viewed as a positive gain amplifier combined with a bandpass filter that provides positive feedback. Automatic gain control, uh, intentional nonlinearity, and incidental nonlinearity limit the output amplitude in various implementations of the oscillator. There are basically the low frequency oscillator that generates audio and sub audio frequency that ranges between 20 Hz to 20,000 Hz. So 2000 Hz. The oscillator circuit uses the wind bridge to provide feedback with the described phase frequency and does not vary much with supply or temperature variation. Wind bridge oscillator theory and working. The circuit diagram of a wind bridge oscillator is essentially is two-stage amplifier with an RC bridge circuit. The phase shift across the network with increasing frequency network and uh, loads with decreasing frequency. By adding wind bridge feedback, the oscillator becomes sensitive to a signal of only one particular frequency. This particular frequency is that at which wind bridge is balanced and for which the phase shift is 0 degree. If wind bridge feedback network is not implied, an output of the transistor, the feedback transistor T1 for providing generation required for producing oscillations. The transistor T1 will amplify signals over a wide range of frequencies, and the direct coupling would result in frequency stability. Thus, by employing wind bridge feedback network, frequency stability is increased. The circuit is set into oscillation by any uh, the circuit is set into oscillations by any random change in base current of transistor T1. That may be due to variation in voltage of uh, supply. This variation on base current is amplified in collector circuit of transistor T1, but with phase shift of 180 degree, the output of the transistor T2 is fed back to the base of second transistor T2 through capacitor C2. Now still further amplified and twice phase reverse signal appeared at the collector of the transistor T2, having been uh, inverted twice, having been reversed twice. The output signal will be in phase with the signal. Derivation of resonant frequency. The frequency at which the oscillator provides the maximum output is known as resonant frequency. R3 R2 1 by R2 by 1 plus I omega C2 R2 equal to R4 into R1 minus 1 by omega C1. It can be also written as R2 R3 equal to R4 in 1 plus omega T omega C2 R2 into R1 minus J by omega C1, or R2 R3 minus R4 R1 minus R2 R4 plus 3 R4 by omega C1 minus J omega C2 R2 R1 R4 equal to 0. By separating uh, real and imaginary terms, we get R2 R3 minus R4 R1 minus C2 by C1 R2 R4 equal to 0, or C2 by C1 equal to R3 by R4 minus R1 R2. Now R4 by omega C1 minus omega C2 R3 R1 R4 equal to 0. Now omega square equal to 1 by C1 C2 R1 R2, omega equal to 1 by under root C1 C2 R1 R2, F equal to 1 by 2 pi root over R1 R2 C1 C2. If C1 equal to C2 equal to C and R1 equal to R2 equal to R, then F equal to 1 by 2 pi CR and R3 equal to 2R4. So this is known as resonance frequency of the oscillator. Application of wine bridge oscillator. These are highly used for audio testing. Clock signal for testing filters circuit can be generated by these oscillators used in distortion testing of power amplifiers. These are also used as excitation for the AC bridges. One bridge oscillator designs the long range of frequencies. It produces sine wave. It is used to measure the audio frequency. Merits and demerits of one bridge oscillator. First merit. Number 1. It is a simple circuit. It provides constant output. It produces high gain due to the due to the presence of two transistors. For a potentiometer can be used with the oscillator to change the frequency of oscillations. Good frequency stability, low distortion. It provides ease of timing. Demerits. It can cause a high output distortion. It cannot generate high frequencies. It has high number of components due to the two transistors. The circuit needs the high number of other components. The limited output frequency is obtained because the amplitude and the phase shift characters of the amplifier. Now moving to the next comes Bristol Angle. In 1815, David Bristol Wishing has observation on a experiment by Malus noted the existence of an angle theta such that if light is incident under the angle of electric vector of the reflected light has no component in the plane of incidence, Bristol angle will exist for either incident polarization at a planar interface separating two media, provided that either a both or both of these media are magnetic. Bristol angle is an angle of incidence at which light with a particular polarization is perfectly transmitted through a transparent dielectric surface. Uh, When unpolarized light is incident at this angle, the light that is reflected from the surface is therefore perfectly polarized. This special angle of incidence is named after the Scottish physicist Sir uh, David Brewster. Derivation of Brewster formula. The relation is defined as mu equal to 10 IP. This equation reflects the polarization by angle mu equal to refractive index of transparent material. IP is equal to polarization, a polarizing angle of incident. Rays of light are vertical to each other, and under the unpolarized light is incident on a transparent medium at any polarizing angle. Also, mu is equal to sin IP sin r, then tan IP equal to sin IP sin r. Mu equal to 10 IP. Here mu equal to refractive index, IP equal to polarization angle. From Snell's law, mu equal to sin IP sin r. From Brewster law, mu equal to 10 IP sin IP cos 10 IP equal to sin IP cos IP. Comparing both formulas, cos I equal to sin r, cos 2 minus r, I equal to 2 minus r, I plus r equal to 2. As I plus r equal to 2 less than ABC, this is also equal to. Hence, we can prove that the reflected and the refracted rays are at right angle to each other. Application of Brewster angle. Brewster window is an application of Brewster angle. It is a glass window which transmits 100% of light. Brewster windows are used in glass lenses and in solid state. In solid state lenses, the ends of the lasers medium is caught at Brewster angle to make Brewster window. And polarized sunglasses. Polarized sunglasses use the principle of Brewster angle to reduce glass from the sun reflecting off horizontal surface such as water or road. Thank you.